You know, for ages, predicting the stock market has been the ultimate holy grail of finance. I mean, fortunes have been made and lost trying to crack that code. But now, with the incredible power of AI, that ultimate question is officially back on the table.
So, can these incredible learning machines finally do what no human has ever consistently done before? Can they actually see the future in the chaos of the market? Well, that is the big question we're going to tackle in this explainer.
All right, let's dive right in. To really get where AI fits into all this, we first have to understand this epic debate that's been raging in finance for like over 50 years. So, on one side, you've got the random walk theory. This idea basically says that all the info we have is already baked into a stock's price, which makes any future moves totally random and impossible to predict. But on the other side, you've got these theorists who say, not so fast. They believe the market isn't perfectly efficient. They argue there are these hidden patterns, these subtle, complex relationships that, if you're smart enough, you can find and use.
And this is where deep learning AI steps into the ring. Think of it as this new contender that's powerful enough to sift through mountains of data, potentially finding those incredibly complex, hidden patterns that humans and, frankly, older computer models could never, ever see. It is the ultimate pattern hunter.
But there's a huge problem, a kind of hidden villain in the data that trips up even the most powerful AI models, and it often leads them to, well, catastrophic failure.
And that villain has a name: non-stationarity. Okay, so what does that mean? The most important thing to get is that the underlying rules of the market are always changing. The average price, the volatility, it all shifts over time. It's like asking an AI to predict a target that is constantly changing its speed and its direction. The game itself is never the same from one moment to the next.
And you can really see this difference plain as day. Look at the left. That's a typical stock chart of raw prices. It's non-stationary. See how it's trending all over the place? It's chaotic. But now look at the right. Those are the daily returns. That data is stationary. It's stable, just bouncing around a consistent average. Now that is a target an AI can actually learn from.
And this whole non-stationarity thing is a disaster for AI for three main reasons. First, the rules the AI learned during a calm market suddenly don't mean anything during a market crash. Second, the AI starts seeing false relationships, mistaking a simple upward trend for some deep, meaningful connection. And finally, the AI is just constantly chasing a moving target, making it totally impossible to find a stable winning strategy.
So, to figure this out, a pretty groundbreaking research project set up the ultimate test. They literally staged a four-way showdown between different types of AI to see which one, if any, could actually handle the market's chaos.
So let's meet our contenders. First up, you've got the ANN. Think of it as the simple rookie with zero memory of what just happened. Then you have the RNN, its predecessor, with a pretty basic short-term memory. In the other corner, we have the LSTM, the complex heavyweight famous for its powerful memory. And finally, the GRU, the streamlined champion, built for both power and efficiency.
So for round one, the AIs were fed raw, messy, non-stationary stock prices. And the results? Oh, it was a complete and total disaster. Every single model, from the simplest rookie to the most complex heavyweight, completely failed. Their accuracy scores were either low or, incredibly, they were negative.
Just how bad was it? Well, in some of these tests, the models hit what's called an R-squared score of negative 0.85. A negative score means the model's predictions were literally worse than if you had just guessed the average price every single day. The AI wasn't just useless, it was actively making things worse.
But then came the rematch. This time, the researchers cleaned the data first. They made it stationary by turning the prices into daily returns. And the result? A complete 180. Every single model's performance just skyrocketed, errors plummeted, and the predictive scores became consistently positive.
But even with this newfound success, one model clearly stood head and shoulders above the rest. The undisputed champion of this entire showdown was the GRU.
So why did it win? Well, the research gives us a really clear answer. The GRU's more efficient design, its streamlined gating mechanism, let it find the real, complex patterns in the data way more effectively than the more complicated and clunky LSTM model.
It's really a classic story of efficiency just beating brute force. The LSTM, our heavyweight, it had so many settings and parameters that it just got confused by all the random noise in the market. But the GRU, our champion, was streamlined. It had the perfect balance of power and efficiency to cut right through that noise and lock onto the true signal.
And its secret is this really elegant two-gate system.
It's got an update gate that decides which pieces of past information are still relevant, and then it's got a reset gate that decides which old information it's probably time to forget. This simple, powerful design is exactly what makes it so perfect for the stock market.
So after this whole showdown, after all this, what is the single most important lesson? Well, honestly, it's probably not what you'd expect. And this right here, this is the most important takeaway of all. The biggest breakthrough in using AI to predict stocks doesn't come from building a bigger, more complex model. It comes from preparing cleaner, stationary data. In the world of financial AI, data prep is, without a doubt, everything.
Okay, so let's just quickly recap the 3 absolute key takeaways here. 1. Making your data stationary isn't optional. It is the non-negotiable first step for any reliable prediction. 2. The GRU architecture is currently king of the hill because it just hits that sweet spot between power and efficiency. And 3. Feeding raw stock prices directly into an AI is a trap. It just creates models that are fundamentally broken and, frankly, worse than useless.
Which brings us to our final question to chew on. We know that today, data prep is king. But what about tomorrow? I mean, new research is already coming out on something called non-stationary transformers. These are next-generation AIs designed specifically to handle messy, raw data from the get-go. Could these future models finally learn to break the very rules we've just laid out? The race to crack the market, you guys, is far from over.